Okay, now for the class today, what we will be doing is solving linear inequations. Linear inequations. Now, remember, when we were solving equations, we found one specific value that satisfied that equation. Now, when we have inequations, we don't find one value, but we have a range of values that satisfy that equation. And here is where we will talk about more than, less than, and so forth. Now, let's talk about what's on the board here. Now, the first one, we have x is more than 5. So if we solve an equation where x is more than 5, what does that mean? X is more than 5. Now, that tells us, what I say, x is equal to every value that is more than 5. Now, note, it means that x cannot be 5. It has to be more than 5. And we can represent the answers on a number line. So, when we represent the answer there, x is more than 5, all the values more than 5. So, we do not include 5. Right? So, from any number more than 5 will satisfy this equation. Now, notice, when we're doing more than, we put a circle and then the arrow in the direction. And the sign helps us to know where the arrow is going. If x is more than, it means that the arrow is heading more to the right in that direction. So 6 can be a member of this set. 7, 8, 9, and any number higher than 5. Now, in this case, we have x is more than or equal to 5. More than or equal to 5. That means 5 is a part of the solution set. 5 is a part of the solution set. Or 5 is a part of the range of values that will satisfy the equation. So 5 is more than or x is more than or equal to 5. And we represent it like this on our number line, where notice, for this one, we color the circle. Here, where 5 was, x was more than, we did not color. But more than and equal to, we color the circle. That means we are including 5 in the set of values. So if we were to list the set of values that represents this equation here, or solution to the equation, we will start from 5 and go onwards, right? Now here, x is less than 5. X is less than 5. So that tells us that x takes every value that is less than 5. Every value less than 5. So 4, 3, 2, 1, 0, -1, and we can keep going on. This arrow tells us that we're going infinitely in that direction, or infinitely in that direction. So any number more than 5 can satisfy that equation. Any number less than 5 can satisfy this equation. And here, when x is less than or equal to 5, x less than or equal to 5, it means it goes from 5 all the way for any number from 5. So we can start from 5, 4, 3, 2, 1, 0, -1, -2. Any number less than 5 will satisfy this equation. So how do we solve these inequations? Let's say we have x plus 4 is less than 9. X plus 4 is less than 9. We go about it doing the same way we would solve a equation. We subtract our on both sides to get rid of our 4. So x plus 4 take 4 is less than 9 take 4. Now, here we will have x is less than 9 take 4 will give us 5. So x is less than 5 will satisfy which equation? If we were to draw the number line, our number line will be like this. X is less than 5. So every value less than 5 will be able to satisfy this equation. Now, why can't x be equal to 5? Notice this is saying x is less than 5. Sorry, x plus 4 is less than 9. So if we put 5 here, 5 plus 4 will be 9. 9 is not less than 9. 9 is equal to 9. So that will not satisfy the equation. But if we use, let's say 4, 4 plus 4 is 8, and 8 is less than 9. If we use 3, 3 plus 4 is 7, and 7 is less than 9. All right? Now, let's do another example here. Now, we have x take 3 is less than or equal to negative 5. X. Now, to get rid of our negative here, remember we add plus 3, take 3, less than or equal to minus 5 plus 3. Now, we will have, this will be equal to 0. X will be less than or equal to negative 5 plus 3. And negative 5 plus 3 will be equal to, since the two signs are different, we subtract. So that will give us 2. And since the 5 is greater than 3, the answer takes the sign of the 5, which will be negative 2. Now, so if we're to represent this on the number line, negative 2, or that would be negative 1, 0, negative 3, negative 4. X is less than or equal to negative 2. So we start from negative 2. Since it's equal to, we have to color our circle, and all the numbers in that direction will satisfy our equation. Right? All the numbers going that way will satisfy our equation. Let's take another example here. We have 2x plus 4 is more than or equal to negative 6. So again, we want to get rid of our 4. Since it's a plus, we will subtract 2x plus 4, take 4 is less than or equal to minus 6 plus take 4. Alright? Now, working on our equation, this will be our answer. This is the way we go about working it. 4 take 4 will give us 0. 2x is more than or equal to negative 6 take 4. Since the two signs are the same, we add. The two signs are the same, we add. So we'll have minus 10. Good. So 2x is equal to minus 10. So to get rid of our 2, since it's multiplying, we do the inverse of multiplication, which is division. 2x divided by 2 is more than or equal to minus 10 over 2. So x is more than or equal to minus 5. Now, how do we represent this on a graph? X is more than or equal to minus 5. So we draw our number line. We can start with 5, minus 5 here, minus 6 here, minus 4, minus 3, minus 2, and so on. So we start at negative 5. Since it's more than or equal to, we color our circle, and we're heading in that direction. When it's more than, we go to our right. So all the values more than or equal to negative 5 will satisfy our equation there. Now, we're going to do some more examples. Okay, let's look at these examples. And when we finish, we're going to be drawing our number line to represent our answer. So let's go right ahead. First, we need to get rid of our 5. And since our 5 is adding, we need to subtract. So we have 2x over 3 plus 5 take 5 is less than or equal to 9 take 5. So that will give us 2x over 3 is less than or equal to 4. Next, we need to get rid of our 3, and since it's dividing, we need to multiply. So, or what we could do is do it at once. Since to get rid of our 2 over 3, since it's multiplying by 2 over 3, what we could do is multiply by the reciprocal of 2/3. The reciprocal means that we upturn the number. So 2 over 3 we multiply by 3 over 2 times 2x over 3. And since we multiply by 3 over 2 here, by 2 over 3, it's less than or equal to 4 times 3 over 2. So if we want, we could take it all over one number at a time, multiply, then divide. But what we can do also is multiply by the reciprocal of our fraction there. So we're multiplying by 3 over 2. So 3 into 3, 1, 3 into 3, 1, 2, 1. So x would remain here. Is less than or equal to 2 into 2, 1. 2 into 4 is 2. 2 3s, 6. So x is less than or equal to 6. If we're representing that on our number line, we have 6. All right, we're going to put a 7 there. 5, 4, 3. So we start at 6, and since it is equal to, we call it a circle, less than. So all the numbers in this direction will satisfy our equation. Let's take another example here, and here we will be careful because I want to show us what's going to happen in a minute. Something special will happen in this equation. First, we get rid of our 3. Since the 3 is positive, so we subtract. So 3, take 2x is more than or equal to 7. Now, that will give us 7 take 3. Minus 2x is more than or equal to 4. Now, we need to get rid of our negative here, negative 2. So we divide by negative 2. Negative 2x over negative 2 is more than or equal to, now, when we have to divide or multiply, if we're getting rid of our coefficient by dividing or multiplying by a negative number, if we are getting rid of our coefficient by multiplying or dividing by a negative number, what happens? Our sign will change direction, right? So once we have to multiply or divide by a negative number, our sign changes direction. So don't forget that rule. Once we're dividing or multiplying by a negative, our sign will change direction. You don't trouble the sign if you're adding or subtracting. It only happens when you're multiplying or dividing. And because we're dividing by negative 2 on both sides, the sign will change direction. So x will be less than or equal to 2. 4 divided by negative 2 will give us negative 2. Right? So representing this on our number line, we will now have minus 2. This will be minus 1, minus 3, minus 4. X is less than or equal to minus 2. So we color our as less than. All right? So that is how we work. Remembering that once we multiply or divide by a negative, the sign will change direction. The inequality sign will change direction. Now let's look at another example. So first, we need to get rid of our, let me make this a little interesting. This is example 6. I will put a minus here. Let's see if we understand what's happening. So, negative 4. How do we get rid of our negative 4? We add. So, minus 4 plus 4 x over 5. Minus 7 plus 4. Alright? Our signs are different, so we subtract. So we have here 0 take x over 5 is less than. Signs are different, we subtract, we will get negative. Since our larger number is a negative, minus 3. Remembering, let's remember that since this is a negative, or since our coefficient is negative, and we will have to multiply to get rid of the 5, and we have to multiply by minus 5 times minus x over 5 is, now since we're multiplying by a negative, the sign will change direction. The sign will change direction. Minus 3 times minus 5. Right? The sign changes direction. So what happens? This will become x, because 5 into 5, 1. Negative times a negative will give me a positive. And then minus 3 times minus 5 will give me positive 50. So x is equal to positive 50. X is more than or equal to positive 50. So let's represent that on our number line. So we have, let's start at 13, 14, 15, 16, 17, 18. X is more than or equal to 15, more than, equal to 50. So that is how we work inequations, solve linear inequations, and how we represent them on the number line. So I'm encouraging you, go to your worksheets, practice so that you will get better at this.